Let's talk more about the challenges space presents to the things we send up into it. Makenzie Lystrup joins us, a former director for the Goddard Space Flight Center, which is NASA's primary hub for building and operating scientific satellites, now principal consultant at Peridot Services, and just an absolute expert in space systems. So there are different degrees of orbital compute, right? Different variations of a space-based data center. But at the extreme SpaceX is presenting, it is at hyperscale. It is running massive AI workloads, inference. Explain the distinction between those three grades of compute and why it's hard.
Absolutely. So the first is really on-orbit edge computing. So this is about taking, imagery data, radar, weather, maritime, climate, or defense data that's collected in space, and then using, AI, edge computing, some kind of inference, some kind of processing in the space system itself before sending it down to Earth. So this is real, this is near term. So a satellite sends raw data to an orbital compute node. The node performs filtering or AI ML inference, and then only the higher value or smaller data products get sent to Earth. So this is a process that the company Axiom says that it deployed as a prototype unit on the International Space Station, and has an orbital data center node as well. Now, the second is really resilient or sovereign storage and computing. So infrastructure that is physically separated from terrestrial threats, so disasters, political borders, or ground-based attacks. That also has some real defense, continuity of government, and critical infrastructure use cases, but still not entirely explored. Now, the third is hyperscale AI work in orbit, and this is really the moonshot. It's potentially enormous, but it is not merely about the launch cost or even the orbital downlink nodes. It really requires some challenges to be met in power, in heat rejection, in radiation-tolerant computing, high bandwidth optical networking, orbital reliability, and other issues. So it's a real challenge.
So let's zero in on some of those challenges, right? Your job was to get systems ready to be in the environment of space. The sci-fi nerd in me thinks about the vast coldness of space. But in thermal, it's a very different challenge, right?
It is. So, space is not cold sometimes in the way that people think. And I would say that in orbit, a data center is a heat engine first and foremost, and a compute platform second. So a terrestrial data center rejects heat through chillers, through air, water, or liquid cooling, through evaporative systems as well. Now, in orbit, there is no convective air heat sink. So heat has to be moved through the spacecraft and then radiated away. So this means that radiator area, radiator emissivity, the attitude control of the spacecraft, contamination, degradation, these are all effects that have now become first-order economic variables.
And then there is the power challenge. There's the belief that the sun is always on. Infinite solar panel as long as there's nothing blocking the path. But again, it's not as simple about that as that when it comes to access to that power.
Correct. So, the pitch for orbital data centers is often that, hey, sunlight is stronger and more continuous in the right orbit. Google's Project Suncatcher argues that solar panels in the right orbit can be up to 8 times more productive than on Earth. So that is true, but just because you have space energy access doesn't mean that you have space energy infrastructure. So you're going to have to deal with some real constraints, and that means the close formation orbital dynamics, the radiation effects, the thermal management, the ground communications. All of this depends on a reliable access to power. And that means power generation, but also power storage, distribution, again, that thermal issue of heat rejection, and also redundancy. Now, this has to be flight qualified. It also has to be able to be reliably operated in space and maintained. And maintenance is one of these hidden costs right now that we're not talking a lot about.
Makenzie, we have literally 10 seconds. Do you think SpaceX can do it?
Well, they're a vertically integrated company that has demonstrated many technical challenges before, so I wouldn't count them out.